Welcome to Groovy and Grails webinar series from JPassion.com. Today's topic is topic number 10, Grails Service. Okay, so let's start with the presentation. So we are going to learn what is and why you want to use a Grails service, and then we will see how we can create and then inject and use that service. And service actually has a built-in transactional feature built in. So we're going to actually see how we can actually take advantage of it. And we'll talk about service scope. And then we will see how you can actually expose your services to non-Grails or even the Grails and non-Grails application using various types of remoting technologies such as JMX, RMI, and SOAP, and things like that. So what is and why Grails services? So the motivation is that business logic should not be in the controller or tech live, because controller should be a very thin layer just for handling incoming requests and then the selecting a view. And the business logic should be in different place. Same thing with a tech live. Tech live should actually focus mostly on UI aspect rather than business logic. So Grails service is the place that you want to place your business logic. So the reasons that you want to use a Grails service is, again, separation of that business logic produces a cleaner code. And business logic, because it's encapsulated in a service, it could be reused in different places in your application. And as I said before, service has a built-in declarative transaction support. So transaction support is built in. You don't have to do anything specific. Just transaction support comes with a service. And it's very easy to inject a service in your controller and tech live or even your domain class. Just define a variable with the name of the service. That's all you have to do to inject that service and use that service. And we'll see that code in a second. So let's see how you can create and then inject and use a service. By the way, as a convention, the service class has to end with a service. So if you are building a sample service, that should actually end with a sample service. Typically, you are going to use a Grails command, Grails create service, and your package and the name of the service. Then it will create a sample service, Groovy, under services directory of your Grails app. And of course, you should have a package directory structure as well. So typically, you're going to use this command. You can manually create your service on the Grails app service directory if you want to. In that case, you have to make sure the name of the service class ends with a service like this. Okay. All right. So basically what Grails does is it scans the service directory and will consider any classes that ends with a service postfix will consider them as a services. Okay, so that's the way you are going to create a service. Now, how you're going to use that service. So first, you're going to inject that service and then use that service. So injection of that service is very simple. All you have to do is define a variable that has the name of the service. Okay, and then it's basically letting Grails frameworks to know that I'm trying to use, I like to actually Grails framework to inject the count service object so that I can use it right here in my code. So once it's injected, I can call the methods of those injected services. In this case, I can call transfer method and balances method of injected account service. So it's basically like auto wiring of the Spring framework, but it's a lot easier to use. Okay, so let's start our first exercise. So here we're going to actually, try to create account app application. And so I already created account app Grails project. And we're going to create a domain class. Okay, so I'm going to create a domain class, new, and domain class. and I'm gonna say com JPassion and account. And then I'm going to add two properties, account name and balance. And I'm going to specify constraints for account name is unique and it cannot be null. All right, so I'm going to just copy this code. Account domain class. Okay. And save the change. And then I'm going to create a controller class. So Grails, new controller, com JPassion and account controller class. And once the controller class is created, we are going to add the business logic to controller. Again, these are the business logic that we want to move to service later on. But for now, we are going to have this one as part of the controller. So the code is basically, we have a two public method, transfer and balances method. So transfer is basically getting amount of the transfer from the user. And then we are going to call two private methods. One is withdraw and the other one is deposit. So we are going to deposit first and then withdraw second. And of course, you can see these deposit and withdraw has to be, these two methods should be performed in transactional manner. Because we have this code in controller, these two methods are not being invoked in transactional manner. So that's the problem that we are going to actually see later on. Okay, and then we want to see the balances. So withdraw method is basically getting the amount. We get the checking account, which is actually from, and we basically subtract the amount to be transferred from the account balance, and the deposit is actually depositing. It's the opposite. Okay, and then the balance is just getting the balance. We get the checking account and savings account, and we just want to display it. Okay, so let's add this code to the controller. Okay, so added this code to the controller. And then we are going to modify Bootstrap Groovy file so that we can create two accounts. So as you can see, we create a checking account and initial balance is $1,000. And we also create a savings account and savings account balance is $500. Okay, so let's go to config and Bootstrap Groovy, and we want to add this code. So basically creating a two accounts, savings and checking and savings. Okay. And we have to import account class. Okay, so let's save the changes. And then we're going to run the application, and then we are going to actually see the balances, and we should actually see the balance. We should see the balance of $1,000 and $500. Okay, so let's run the application. And then we're going to perform transfer operation. So here we are going to call transfer method, and the from account is checking and to account is saving, and amount we want to transfer is $100. Okay, so let's see whether it's running. Okay, so we're going to wait a couple more seconds. And once that is done, the amount of checking account balance should be 900 and the savings should be 600. Okay. All right, so that's done. So let's, well, we can actually go to, we can just check the balances. So the balance is $1,000 and $500 as expected. And then we are going to transfer. So here, I'm gonna click this link, and as you can see, the checking balance is now $900 and savings balance is $600 as expected. So that's cool. All right. Now, as I said before, having business logic in the controller is not recommended practice. So we want to create a service and we want to move the logic of transfer and balances to service. So let's create a service. So you can actually create a service by calling create service and then specify the name of the service. Okay. So here, right click and new. And let's see whether we can find the service right here. And we're going to say com JPassion and account service. And basically, we want to move the business logic that we have seen in controller to the service. Okay, so that's what we want to do. So the logic we want to the transfer from the controller is again transfer, withdraw, and deposit, and balances. We want to actually copy all, this code. So this is actually from the controller, and then we will change the controller. Okay. Okay. And then we are going to change our controller. So this is the way that you are going to inject account service. So only thing that you have to do is basically specifying a variable that names that service. Okay. So let's go to controller class and we are going to remove all this. So I'm going to just copy this code. Again, the code is very simple. So here we inject the account service and then we are going to call account service object transfer method and then we pass the value. Okay, so from account, which is checking, and this is saving, and then we are going to convert the amount coming from the client to integer and pass it to transfer method that we have here. Okay, and then we direct balances. As far as the balances, we are going to just call balances method of the account service. Okay, so I'm going to just copy this controller code and replace this controller code. All right, so now we are going to see whether that works or not. So let's actually see where the we get the existing balances, which is supposed to be 900 and 600. So let's see whether that works. Okay, so that works. So instead of using controller as a business logic location, now we are using service as a business location, a business logic location. All right. Now let's try to so let's try to actually the transfer $50. So here from again checking account to savings account amount is $50 transfer, and the results are supposed to be $850 and $650 as expected. So that worked. Okay. All right. So that worked. Okay. So let's move on to the transaction. So why declarative transaction? So you can actually have a programmatic transaction using with transaction method. So sometimes, if you want to have a fine-grained control, you could do that. Okay. However, you typically want to use a declarative transaction because it's built in. So services has a built-in transaction features. So any method in service has a built-in transaction demarcation. Okay, so all services, meaning all methods of a service, are transactional by default. If you want to disable that built-in transaction, then you can specify transaction equal false. Then there is no transactional feature built in each of the service, each of the method of the service. So transactional behavior. So basically, all methods in a service has a built-in transaction. Now, if there is an error, it has to be a runtime error, by the way, in that method, then everything will be rolled back by the Grails. Okay, so all methods are wrapped in transaction, and automatic rollback occurs if a method throws the runtime exception. It has to be a runtime exception or error. Checked exception do not cause the rollback transaction by the Grails. Okay. Also, you can specify propagation level of the transaction. So, there are actually 6 propagation attributes you can specify. Propagation required is default. Okay, and propagation required new. So I mean, these are probably only two that you might actually see once in a while. Okay, and these are exactly the same as you see in EJB transaction attribute. Transaction required is that the transaction has to be provided. So if the transaction is already present, then that's the one that will be used. If it is not present, it will create one. Propagation required new is actually creating a new transaction regardless. So if there has been already a transaction, that transaction will be suspended and then new transaction will be created. So we're going to take a look at this in hands-on lab exercise later on in a bit more detail. All right, so let's do exercise 2, which is the declarative transaction. So in this exercise, what we're going to do is we are going to see the non-transactional behavior causing inconsistent the data state. Okay, so let's take a look at what we're going to do is we're going to actually change the controller code to old code. Okay. So we have a business logic in controller. Basically we want to experiment this inconsistent data state because you are not using transaction. Okay, so we also want to add some error checking condition in withdrawal. So when the user is trying to withdraw the amount that is bigger than the initial existing balance, then we want to throw runtime exception. Okay, so you might want to actually create another exceptions, for example, like a not enough fund exception or something like that. But for the sake of simplicity of this exercise, we are just throwing runtime exception if the balance is smaller than the amount, the existing amount. Okay, and then transfer will actually catch that runtime exception, and then it will just display the message. Now, please note that we are actually depositing it first, and then withdraw. Okay, the reason we want to actually try deposit first is to do experimentation so that deposit is already done, right? And then if there is a problem in withdrawal, we are going to actually see inconsistent data state. Okay, so we are going to change this controller code with this. Okay, again, this is kind of not using the service. Okay, just to experiment this problem. Okay, so we save the change, and just for the sake of actually seeing the initial balance 1,500, we're gonna just stop it and restart it again. Okay. So let's make sure the balance is $1,500. And then we are going to transfer, this time $5,000 from checking to saving. And obviously, the checking account initial balance is 1,000. So obviously, this is not the it should not be allowed. Okay. So withdrawal the method in this controller should throw runtime exception. Okay, and then but again, we perform the deposit first, and then we perform withdrawal. Okay, so in this case, what we are going to see is, so let's actually see the initial balance. Okay, so $1,500. Now let's try to transfer $5,000. Now you can see deposit already is done. So the savings account already have a $5,000 added to it, and the checking account, because withdrawal has an exception, this didn't change. So you can see inconsistent state in these two tables. So this is because we have not performed this deposit and the withdrawal in transactional manner. Okay. Okay, so for now, there are a couple of options to solve. The first option is in the controller, you can actually perform these two using with transaction, but obviously that's not really desired. You won't take advantage of built-in transaction features of the service. So what we want to do is now we're going to actually change it back to this controller code is going to be change it back to to use the service. Okay, so now we're going to just change it back to this controller to use the service so that we can take advantage of transaction behavior of the service. Okay, All right, so now we transfer, and this is exactly the same code that we have seen, except that we basically checking the whether there is in fact the runtime exception or not. Okay, so that's the only change we made. Now we want to change the service so that the withdraw method also check whether the amount that is being transferred is smaller than initial balance. Okay, so we are going to change the service code. So withdraw. We are going to add these 3 lines of code. So if the existing balance is smaller than the amount, we want to throw. We're going to actually do right here. We want to throw runtime exception. Okay. All right. So now let's try to restart so that we can actually start from the the initial balance. Okay. And okay. So we want to start from 1,500. Now, when we try to transfer $2,000, okay, you can see the data is consistent because now transactional behavior of the service will roll back the whatever change that has been made when there is actually a problem. Okay. All right. So let's try to see the initial balance. Again, $1,000 and $500 as expected. Now let's try to transfer $2,000, okay, which is bigger than the checking account balance. Okay. Now you can see, oops, why is actually it's no problem. Oh, maybe I didn't save the changes. Okay, sorry about that. So let's stop again. And we'll start it again. Sorry about that. And we also have a debugging message right here. So, when in the transfer, when there is actually, this is the, in the controller, when there is actually a problem, when there is a runtime exception, we just display it. Okay. All right. So let's actually try the initial balance first. So $1,500. Now let's try to transfer $2,000. Okay. So as we can see, the data is consistent because the deposit operation has been rolled back because of the transactional behavior built in the service. Okay, and you can see the message. An exception occurred during the transfer. That is actually from the controller right here. Okay. All right. Okay, so we have done that. Now let's turn off the transaction as an experiment. Okay, so you can turn it off. You can turn the transactional behavior of a service off by using static transaction false. If you set it to true, that's the default. Okay, so let's try to turn it off and see whether we are going to experiment. We are going to see a problem or not. Of course, we are going to see the problem, right? So we go to service and let's turn the transactional behavior off. Okay, save the change, and then let's start again from the beginning. Okay, and then run it. And then if you actually try to the transfer $2,000, and then you can see inconsistent state because we turned off the transactional behavior of the service. Okay. Right, so let's actually do the initial state first. Okay, so initial state is $1,000 and $500, and then what we want to do is so we have turned it off, and now we are trying to transfer $2,000, and now you can see inconsistent data state is resulted because of the transaction was turned off. Okay, all right, so here now if you change it back to true, that means that's the default. So you can actually having this one and not this one, this is the same thing because transactional is true is the default. Okay, all right, so if I actually try again and run it again, then we should actually, so this is a default, and then we can take a look at the balance, and then if you try to transfer, it should not allow it. Okay, so that should actually work as expected. All right, so let's try to see the balance. So that is the initial balance. Now if you try to transfer $2,000, and that should not be allowed. Okay, all right, so everything looks good. Okay, so let's move on to the next topic. So we just take a look at the declarative transaction in service. You can actually specify custom transaction using @transactional annotation. So you can have a fine-grained control by using this annotation. By specifying this annotation, you are basically using a transactional false. You know, this is the same thing. Whenever you are using @transactional annotation, either at the class level or method level, basically you are saying to Grails that you want to have a fine-grained control yourself, meaning the built-in transactional feature of a service is going to be turned off. It's the same thing as the transactional false. Okay, all right. So you can have a transactional annotation at the class level or method level. If you have it at the class level, all methods of that service will be inheriting this transactional behavior. And of course, if you specify a method level, then that will override the class level. So let's say an example. So here, I'm specifying transactional annotation with read-only true because listing books you should not actually change any state on the server, so it doesn't have to be read-write the transaction. Okay, so it's going to actually provide a better performance. Okay, so basically you're saying is that I want to actually perform this list books operation in the form of read-only transaction, meaning it's faster. Update book, because you are changing things on the server side, you want to actually have we want to have it performed with default read-write transaction. In this case, if you don't specify anything, this is not transactional. Okay. All right, so let's do exercise 3. So we want to have a fine-grained control on transactions. So in our case on the service, we are going to use this transactional at the server, the class level. Okay, so basically, this is the same thing. Whenever Grails see this transactional notation, it will actually consider transactional. It is set to false. Okay, now we want to import this transactional class. Okay, so in this case, for example, like a balances, it doesn't have to be the read-write transaction. So we want to actually have it as read-only true. Okay. And because we have not specified anything on the transfer method, basically it's taking this transactional annotation attribute and it's using default read-write the behavior. Okay. All right, so we save the change, and it should actually behave exactly the same. Okay, so let's run the application again. And we'll start from the initial balance. And let's try to transfer $2,000, and it should not change. It should not actually allow it. So that's the result, which is what we expect. Okay, so let's see the initial balance. Okay, so $1,000 and $500. Now let's try to transfer $2,000, and it should not allow it. Okay, and we should actually see this debugging message from the controller as expected as well. Okay, now the reason that you want to use the transactional annotation is because you want a fine-grained control. Okay, so one fine-grained control we want to exercise is the propagation. Okay, So for the transfer, we want to use propagation required, and for withdrawal, we want to use required new. So in this case, what it means is that whenever this method is invoked from a caller, in this case a controller doesn't have a transaction. So in this case, it will create a new one. Same thing with withdraw. So because the controller does not have a transaction, it will actually create a brand new regardless. Okay, so in this case, suppose a controller code has a transaction, maybe using with transaction method or something like that, then the transaction object is going to use is the same transaction object from the controller. Okay, so that's basically propagation required. In this case, it's going to create a brand new transaction regardless whether controller caller has a transaction object or not. Okay, so in this case, again, the behavior is going to be exactly the same. Okay, I just want to actually show you how you can actually specify more fine-grained the propagation. Okay, so if you want to actually see the propagation information, you just click this link and you can actually see required, new, and things like that. Okay, so this is exactly the same as the EJB transaction attribute. Okay? All right, so let's actually do this one. Again, the behavior is behavior we are gonna see is exactly the same. Okay, so we are going to use transactional required for the oh, you know what? Yeah, so this code, I mean, I actually meant it yeah, actually I should not have this one. Okay. Oh, okay, you could actually have this one. Yeah, so withdraw. Yeah, this is what I meant actually. Yeah, even though this is a private method, I can specify the transaction. Okay. So yeah, because oh yeah, so basically, yeah, so this is the example. Sorry, I think. So this is the transfer method is invoking this withdraw method, right? So withdraw method is creating a brand new transaction object instead of actually using transaction object of the caller, in this case, a transfer method. Okay, so yeah, sorry, I think I actually, explained in a bit in a wrong way. Okay, so in this case, the transfer is the calling method, and withdraw method is the callee method. Okay, so callee method in this case is going to create a brand new transaction. Okay, again, behavior is exactly the same because we are not actually doing anything fancy. Okay. Okay, now we want to import this annotation, transaction annotation class. Okay, and save the change and refresh. Stop the server and we are starting again. And again, we are going to see the initial balance. And if we try to transfer $2,000 again, it should be taken care of. Okay, so that's what we are going to see. Okay, it's done. So let's see the balance. And then let's see if you can transfer $2,000, and that should not be allowed. Okay, so it worked as expected. Okay, so let's move on to the next topic, service scope. Service, as a default, is a singleton scope, meaning there is only one service object for the whole application. Okay, so what that means is that the states that you maintain your service object, they are shared by everyone. In general, it's a good idea not to have any state on the service, but if you happen to have a service, you have to actually make sure they are not really kind of, written unexpectedly, overwritten unexpectedly. Now, you can specify the scope of service. So as I said before, singleton is a default, meaning there is only one the object. And then you could have prototype, request, flash, flow, conversation, and session. Okay. So the way that you can specify your service scope is by specifying, so let's actually do exercise 4, specifying static scope, and then you specify singleton. So what you're going to do in this exercise, so let's do exercise, exercise 4, we're going to have a state, the counter, okay? And let's actually see how this counter is going to be accessed. So this is a default, okay? So singleton is the default. Okay, we are basically explicitly specifying it. So let's go to this transaction service, and we're going to add these 2 lines of code. Okay, and that's the default. And when we call balances, we want to display the counter value. Okay, so I'm going to just copy this whole thing and change this code. Okay, we're basically displaying, in addition to balance of checking and savings, we also display this counter value, okay, which is a state maintained in the service object. Okay, so let's save the change. And let's refresh the browser. So let's actually see. Now, if I refresh the browser, I can see the counter value. Now, if I click this one, you can see these values are being updated. Now, I'm going to actually open oops. I'm going to open another one. Yeah, I'm going to, oh, this is the one I opened. So I'm simulating another user. So I'm going to copy this link and here you can see it's picking up the same value. So if I refresh this guy, it will increment. Okay, now if I go back to another one, the first user, and if I again refresh it, you can see it's picking up the value from here, which means this counter state is is actually per application. So all the users will actually see that value. Okay. All right. Now what we want to do is we are going to change this value. So that's what we just see. Now we're going to change this scope to session. Okay. So what that means is that this counter state will be maintained per session basis. So if each user will have a different value. Okay. So let's change this one to a session. And let's save the change. Okay. Now let's see. So I'm going to actually go to the here. So we are going to see these values. This is one user, first user. So this value is actually keep changing. Now if you go to different user, and now if I actually refresh the page, it's going to start its own. Okay. And the values on this user should not affect this user. So if I go here, it will actually have its own counter state, while the second user has his or her own state. Okay, because we changed the state scope. I mean, we changed the scope of the service to session scope. Okay. All right. So that's basically session scope. And now, if you change the requested scope, then this is gonna be updated per each the request. Okay, so regardless of the refreshment, it's gonna be always one. Okay, so let's change this one to request scope. Save the change. Now if I go back to the link balances, so it's always one. Okay, because every time I send a request, it's going to be recreated, meaning the service object gets recreated. Okay, all right. So that is the scope exercise. So let's move on to the last topic, exposing service. So what is and why exposing services? So services can be exposed to other applications. So if you think about it, Grails Service is business logic, and this business logic could be exposed in the form of, for example, like a web services, okay, or GMS, the managed resources, or RMI services. So Grails actually provide the feature of exposing services just for that, right? So it's very nice. I mean, so by using remote technology, so you can expose your services as managed resources of using JMX, or you could actually expose them as a SOAP-based web services using CXF or Metro, or you can actually expose them as the RMI services using RMI, okay? So the way that you're going to actually have these services to be exposed as this you know the services, exposing services to other application. By the way, these other application could be Grails or non-Grails application. So if you're exposing your services as a SOAP-based web services, then any client that can actually send a SOAP request should be able to access your Grails service business logic. All right, so you have to actually install plugin for each of those the remoting technologies. So here we're going to actually try JMX, meaning we want to expose the services, Grail services, as a JMS resources, meaning they are being managed by JMX. Okay, so latest version is 08, so we're going to use that, and then you are going to specify how you're going to actually expose your service by using expose property. So here you can have an array like a JMX and CXF and things like that. So here I'm actually exposing my account service as JMX. All right, so let's do our final exercise. First of all, let's take a look at the JMX plugin. So you can go to grails.org plugins, okay, and then you can search JMX, and you should be able to see JMX plugin. And the way that you are going to use your JMX plugin is by having this compile or runtime of this one in your config file. Okay, so not config file, but let me actually show you. So basically, you take a look at this one. You're going to actually change a build config file. So this is the way that you're going to configure a particular plugin. You can call the Grails install plugin and JMX at the command line. So that's that's allowed. But in general, it's a better practice to change this build config.groovy file to configure your plugin. Okay. So we are going to change the build config of this. And then we are going to add this line. So this plugins enclosure, so this closure, you specify all the plugins that you want to install in your application. So these are built in. I mean, these are provided as a default. Okay. So now we are adding JMX plugin. Okay. All right. Now we save the change. Okay, now we might have to, okay, now we have to expose the service. So we actually go to account service, and then we are going to expose this JMX like this. Okay, save the change, and we're going to restart. And then we are going to restart the application. Now we're going to actually run JConsole. JConsole is the application that comes with the JDK. So JConsole is a JMX client application. So it will actually manage all the JMX resources. Okay. So once this is up and running, then we are going to actually open JConsole. So let's wait until this is up and running. Oops, what happened? Having a problem. So error being name the account service scope. Oh, so I should actually have the scope should be. I'm gonna just comment this out. Save the change, and we will restart. And once this is up and running, then we are going to run JConsole. So JConsole will actually list all the Java processes that it can actually manage. And we are going to actually select this Grails starter. And we are going to actually see whether it will detect our account service as a service. I mean the JMX resources. Okay, all right, so it's up and running. Now let's run the JConsole. Okay. All right, so JConsole will list all the Java. So this is the one that we want to connect. And now we want to see all mbeans. So mbeans are basically all the managed resources. Now you can see we have this account app. And if you take a look at this, I can actually see all the data sources and all the service as well. So this is actually what we are interested. So you can see account service has a 3 operation, balances and get counter, and should actually have a transfer. So transfer right here. Okay. So we can certainly get the get counter value. You know, you can see the counter value is 1, and we can actually see the balances. So you can see the balance is $1,000 and the savings is $500 and counter is 1. Okay, so that's basically what it does. You can I'm going to actually add an exercise later on so that the services are being exposed as SOAP-based web services. Okay, all right. So that's the end of today's presentations.